Right, so learning target number 4 is the same as what we've been doing, but now we're on an incline. Okay, that's the only difference. That's the only change that we're making. Okay, so if I'm looking at the skier on the incline, what forces do you think are acting on that skier? Because I would say that there's a force due to gravity, and the force due to gravity is going to be directly down into the earth. Okay, some force due to gravity. And then there's the hill pushing back up on the skier. That would be the normal force. Now here's the most common mistake that I see. This normal force is not straight up. It's not the opposite of the force due to gravity. Remember that normal force is perpendicular to the surface that supplies that force. So we need to do a normal force that's perpendicular to the surface, right? It makes a right angle with that surface, okay? What other forces are involved? There's no thrust, there's no engine. There's maybe a little bit of friction, which would be pulling them back up the incline, right? The force of friction. Okay, so if I were to draw this free body diagram, I'd say I have my force due to gravity. I have my force normal, and then I have my force due to friction. And I want you to notice here, if this is perpendicular to the incline and then the friction's pulling it up that incline, then that's a right angle as well. So this right here, that's a right angle. Okay? Okay. So same thing that we just did. We have our force normal, which is perpendicular to the surface. We have some friction pulling it back up. This shouldn't be an arrow because this is not a force. That is just the x component. Like it's saying, what we're saying is instead of, back to this, instead of calling this y and this x, because if we call that x and that y, then we have an x and y component of the normal force as well as the force due to friction. But as the observer, I can shift my coordinate system. And what if I say that the incline itself, that's going to be my x direction, and then perpendicular to that off of the incline is going to be the y component. Okay? And so this friction, which is in line with the surface, that's going to be on the x-axis. And then the normal force, which was perpendicular to the surface, that's going to be my y-axis. Okay? Now I want to redraw this. I'm going to simply take the diagram and I'm just going to shift it upright so it's just a little bit easier for us to see what's going on there. So we've said, according to this, that our friction is going to be in the x, and that our normal force is going to be in the y. Okay? And then so see, here's my y-axis, here's my x-axis. And if this is my y-axis, well, gravity is inside the x-axis, the y-axis, away from the friction. So gravity comes off like that. Okay? Now, last part of this. Whatever the angle is of the incline, through some geometry and some skills, we can prove that it's the same angle here. Okay, so if you know the angle of the incline and then you shift your axes like this, then you also know the angle in between the y-axis and gravity. Okay, with those skills in mind, let's look at practice problem, example number 1. A 62 kilogram person on skis is going down a hill. The slope of the hill is 37 degrees. The coefficient of kinetic friction between the skis and the snow is 0.15. How fast is the skier going after 5 seconds? You're going to need to add that in. We forgot that on our guide notes, so it's after 5 seconds after starting from rest. Okay, let's draw a picture, establish a coordinate system. Okay, so we have a skier. And they're going down a hill. The angle is what, 37 degrees? Okay. Here's the skier. Okay. And so we're going to call the slope our x-axis. Okay. And then we're going to call the perpendicular to that slope, where the normal force is going to be, that's going to be our y. Okay. So if I were to draw a free body diagram, I'd say I have force due to gravity going straight down. I have friction that's holding it up the incline. I have a normal force which is perpendicular to the incline. And I think those are the forces acting on it. But I've shifted my axes, so this is now the x-axis, and this is the y-axis. Okay? Let's redraw it. Let's just turn it so it's upright, so it's kind of easier for us to view and see what's going on there. So I would say that my force normal is in the y. I would say that my friction is in the negative x-axis, and that gravity is here. Okay? Force due to gravity. And remember, this angle is the same as that angle. So this angle right here, that's our 37 degrees. Okay, perfect. Now, we want to know what the acceleration is in the x direction, right? The x is going down the slope. We want to know what that acceleration is so that we can determine how fast they'll be going after 5 seconds. So let's see, what are the sum of the forces in the x direction then? It's going to be mass times by acceleration, and that's what we're looking for there. So we have some of the forces in the x. Oh, let's look at force due to gravity. It's going to have force due to gravity in the x direction as well as force due to gravity in the y. Let me see where we're at on time. Yeah, let's take a moment to calculate what those are. Okay, so if this is our magnitude, well, force due to gravity, that whole magnitude is mass multiplied by acceleration due to gravity. Okay, so that would be the mass of the 62 kilogram person multiplied by 9.81 meters per second squared. Okay, so then when I multiply those together, I get 608 newtons. Okay, so I know my force due to gravity, but what about the x component? Well, the x is opposite from that degree. So force due to gravity in the x is going to equal force due to gravity, the hypotenuse, sine, because it's opposite, theta. Okay, so force due to gravity in the x is going to be 608 newtons sine of 37. And then that's 366 newtons. And then force due to gravity in the y, that's going to be 608 newtons cosine 37. It's going to be 486 newtons. Okay. So back to the sum of our forces here. We have a positive in the x direction, force due to gravity in the x, and then we're minusing our force due to friction. And that's the only forces in the x direction. So that's going to equal mass times by acceleration. Okay. Well, we know what the force due to gravity in the x is. 366 newtons, minus friction, which is mu k times by force normal, and that's going to equal mass, which is 62 kilograms, multiplied by acceleration. And remember, this mu k, this coefficient of friction, is 0.15. Okay? And so we have this. The only thing we don't have is that normal force. So let's look at the sum of the forces in the y direction, see if we can determine that. Now, sum of the forces in the y. Remember that the y is perpendicular to the surface here. So we're not raising off of the incline and we're not sinking into the incline, right? As far as the y direction goes, we're staying in the same place. And so that means our velocity is constant, our acceleration is constant, or sorry, our acceleration is 0, which means the sum of the forces is 0. Okay? Now what's going on with the sum of the forces? Well, we have force normal, and then minus the y component of force due to gravity. So force normal is going to equal the force due to gravity in the y. And we solved for that. We know that is 486 newtons. So we can plug that in here. So I'm going to take 486 multiplied by 0.15. So now I have 366 newtons minus that 0.15 times by 486. Okay, and so that is 73 newtons, and that's going to equal 62 kilograms multiplied by acceleration. If I subtract those, that's going to equal 293 newtons, and then I'm going to divide by the 62 kilograms, and that will tell me that the acceleration is 4.73 meters per second squared. Okay, so we know the acceleration. So now we can do this last little part. Because it didn't ask for the acceleration, it said how fast is the skier going after 5 seconds. Well, let's see where we at time-wise. Yeah. We have acceleration is a change in velocity. Velocity final minus velocity initial. Divided by time final minus time initial. It says that they're starting from rest. After starting from rest. So velocity initial is 0. Time initial is 0. So acceleration is velocity final divided by time final. But we want to know how fast he's going, so that's velocity final. So I'm going to multiply time final to both sides. So velocity final is equal to acceleration multiplied by time final, or 4.73 meters per second squared multiplied by the 5 seconds. And that gives us 23.6 meters per second. That's our final answer there. Okay, so when we return for the next video, we'll do at least one other practice problem. Okay.